Hello, is this where the genie is?
Hello. Yes, this is where the genie is. I will give you one wish, and I'll give you whatever you want. So what do you want on this snowy Friday afternoon?
One wish? I know exactly what I want. I want to know if we're going to have a snow day on Monday. It snowed today, but it's all going to melt over the weekend. I want to know how many inches of snow will fall on Monday, 3 days from now.
About that one. I don't think I can help you with that one, young boy.
Why not? I thought you could give me whatever I wanted.
Well, about that, I can only give you the formula of dy dx of the graph of the inches it will snow over a time period, and the exact value at the current time. I cannot give you the formula for f of x, so I cannot show you the exact value of f of x. Sorry, any other wishes?
Actually, if we use this method called Euler's method, we can approximate the value of the function at a specific point.
Really? What is Euler's method? Can you show me how to use it? Has it been proven to work?
First off, yes, it does work. It was created in 1768 and has been used to solve problems like this since then. It is used on a first differential equation with a given initial value to approximate a value a little higher or lower than the original value by using a formula to go up or down an equal amount each time until you hit the desired value.
Wow! How interesting. I never knew this. Can you teach me how to do it with the derivative equation and initial value I give you?
Yes, of course. I can show you how to do it. So, what is the equation of the derivative?
Well, if we come over here, we can see the derivative equation that the genie gods have given us. dy dx is equal to x minus 2y plus 2.
Well, let's see. So, today, 2 inches snowed. So we can say that f of 0 equals 2, saying that 0 is today. Now, we're looking for f of 3. That is the question. So, what we're going to set up is a little chart here. First, we've got x's. Now we're starting at 0, 1, 2, and we're going to 3. Our y value is starting at 2. This is going to be our y value. And then here is our dy dx. So, we plug in the numbers from here to get our first dy dx. This becomes 0, this becomes -4, and this becomes +2. So dy dx for the first segment is -2. Now the length of the segment is 1, the difference in the x value. So we multiply that by dy dx to get the change in y. So dy dx times the change in x equals the change in y for every step. So -2 times 1, if we add 2 to -2, we get 0. Now we can calculate dy dx again. This time x is 1, y is 0, and we add 2. So that just becomes 3. 3 times 1 is 3, so we add 3 to y. Now we plug in again, we get 2 minus 6 plus 2. That gets you -2 for our dy dx. Again, we multiply that by the change in x, which is just 1, and then we change the y value. Now, and 1 is your answer. That means we're going to get approximately 1 inch of snow on day 3, which we'll call Monday.
Wow, that's crazy. I never knew you could do that.
Yeah, that's the power of Euler's method.
Alright, you can stop it. Would you look at that? Snow on Monday. Wow.
Well, it might be an approximation, but Euler's method is a great way to see what value of a function might be after a certain amount of time.
Wow, thank you so very much for teaching me about the so-called Euler's method. I will be sure to use it in future endeavors. You know what, buddy? Just for you, I'm gonna give you a second wish. Something I don't usually do.
Oh my gosh, Mr. Genie, thank you so much. Wait, what's that? Is that a TV broadcast?
No.
Good evening, Camden County. This is Channel 3 News. This just in, there will be approximately 1 inch of snow on Monday. Boom chakalaka. If you are in one of the following schools, you will have off Monday for the snow. Haddonfield. That is it for breaking news today. Thank you, folks. Now to Babatunde in Chicago.
Eat like a king who's on a budget. 3 tasty options, fries, drink, and nuggets, all for $5. Wait, that can't be right. Just confirm that that's the real price. BK, have it your way.
Wow, Euler's method really does work. I'll be sure to implement this concept into my everyday life.
Yes, it does. I use it almost every single day. For my second wish, I wish for you to try an Euler's problem that I give you.
For me, you know what? Okie dokie. I accept your challenge.
Alright, here's the problem. Now I already did the Euler's method. I want you to figure out what my starting point was. This is your equation, and this is what Euler's method gives you when you use a step size of 0.5. Tricky, tricky, tricky.
Wow, that is quite an interesting problem there, young boy. So I'm gonna do what you did. I'm gonna set up our little table here. So we'll start with x, y, and dy dx. dy dx. Now you know x goes in intervals of 0.5, starting at 1. So we got
Yes.
1, 1.5, and 2. Now f of 1, you said that is equal to k. So I'm gonna go with that. And f of 2, you said that's equal to 4. So we're gonna go with that. So now we have to find our dy
Approximately.
dx. Approximately equal to 4. Sorry. Now we gotta find our dy dx for our first value. So I'm gonna plug x in, which is 1, and y in for k. So dy dx is 2 times 1 plus k. So 2 plus k. Now, for our second number, we need to solve the second y. And in order to do that, we have to use that Euler's method formula that you showed us earlier. So we've got k plus this derivative, 2 plus k, times the step size, which you said was 0.5. This ends up giving us about 1 plus k plus another k. So we've got here 1 plus half a k plus another k. So 1 plus 3 halves k. So I'm going to put that in for our y value for 1.5.
Looking good.
Thank you, thank you. Now that we have this y value and this x value, we can solve our second dy dx at 1.5. So in order to do that, I'm going to do plug 2 in for x again, or 1.5 in for x, sorry. 2 times 1.5 plus y, which we know is 1 plus 3 halves k. So plus 1 plus 3 halves k. Now, I'm going to keep solving this to get 3 plus 1 plus 3 halves k, which to me is looking like 4 plus 3 halves k. Would I be correct there, young boy?
That looks good to me.
All right, thank you. So we got this. I'm going to put this back in for my dy dx. Now, using our Euler's method equation again. Sorry. We can solve for y here by using k solving for 4. So let's plug that into our equation again. We've got 1 plus 3 halves k, this plus 4 plus 3 halves k is equal to, or times, 0.5 our step size, and this is equal to approximately equal to 4. Now, we can just do the algebra here out and solve for k. So, we can keep this 1 plus 3 halves over here. And over here we can put the 0.5 out, multiply the 0.5 out to get 2 plus 3/4 k. And that is still approximately equal to 4 here. Now, if we just combine like terms by changing this to a 6 halves, or 6/4, we get 9/4 k plus 3 is approximately equal to 4. Now, if we just keep solving this out, minus 3, we get 9/4 k is equal to 1. And in result, we get k is about equal to 4 nines.
Wow, that looks correct. You go, girly pop.
Oh, look at me. Thank you so much for teaching me how to do this new Euler's method.
You're welcome, brother O.
All right, tell me when you start. All right. Hello. Who is this?
This is Brady Norton.
Hello, Brady. So, Brady, would you want to do one Euler's method problem, or would you like to double it and pass it on to the next person?
I'd like to double it and pass it on.
Hello, what is your name? Would you like to do 2 Euler's method problems or double it and give it to the next person? Thank you.
Hi, Jack.
Hello, what is your name?
Daniel.
Okay, would you like to do 4 Euler's
Daniel
method?
Plum.
Would you like to do 4 Euler's method problems, or would you like to double it and give it to the next person?
Double and give it to the next person.
All right, thank you.
Hello. Who is this? Who am I here with today?
Alec Conover.
So, would you like to do 8 Euler method problems, or would you like to double it and pass it on to the next person?
Double it and pass it on.
Thank you. Here today?
Bodie McIntyre.
All right, Bodie. Would you like to do 16 Euler method problems, or would you like to double it and pass it on to the next person?
You know I had to double it.
Facts.
Yo. What's your name? Cole. Would you like to do 32 Euler's method problems, or double it and give it to the next person?
Double it.
Thank you. Yo, hello. Who am I here with?
Peter Landis.
All right. Would you like to do 64 Euler's method problems, or double it and give it to the next person?
Double it and give it to the next person.
Awesome. Thank you.
Hello. Who am I here with today?
Chase DeGilio.
So, Chase, would you like to do 128 Euler's method problems, or double it and pass it on to the next person?
Can you restate the question?
Would you like to do 128 Euler's method problems, or double it and pass it on to the next person?
Double it.
All right, thank you, Chase. All right, what's your name?
Henry Cowan.
Would you like to do 256 Euler method problems, or pass them on to the next person and double it?
Do 256 math. What problem?
Oh, look at that!